Unlike terms have the same pronumeral parts, like 5x and 7x and negative 2x. Unlike terms have different pronumerals, like 4a and 3y and 7w. I need to know, just when can I simplify, and when I can't. So I say, go get your terms if they're like terms, put them together. If they're unlike, keep them apart. Yeah, I said, go get your terms if they're like terms, put them together. If they're unlike, keep them apart. Go get your terms if they're like terms, put them together. If they're unlike, keep them apart. Order doesn't matter when you multiply. So A, B, and B, A are like terms. A number and its square are hardly ever the same. So X and X squared are unlike, you can't simplify. I need to know, just when can I simplify, and when I can't. So I say, go get your terms if they're like terms, put them together. If they're unlike, keep them apart. Yeah, I said, go get your terms if they're like terms, put them together. If they're unlike, keep them apart. Yeah, I said, go get your terms if they're like terms, put them together. If they're unlike, keep them apart. Say, go get your terms if they're like terms, put them together. If they're unlike, keep them apart. So if they're like terms, go, go, go. If they're unlike, stop, don't you combine. If they're like terms, go, go, go. If they're unlike, stop, stop.
On your marks. Set.
Yeah. Go get your terms if they're like terms, put them together. If they're unlike, keep them apart. Yeah, I said, go get your terms if they're like terms, put them together. If they're unlike, keep them apart. Yeah, I said, go get your terms if they're like terms, put them together. If they're unlike, keep them apart. Yeah, I said, go get your terms if they're like terms, put them together. If they're unlike, keep them apart.
how we can simplify algebraic expressions, where numbers and letters are being multiplied together, like in these examples. Now, the most important thing you need to know when you're doing algebra is that we generally don't write the multiplication signs, and instead we just put the figures that are being multiplied together right next to each other. So for this first question, instead of writing A times B times C, we'd get rid of the multiplication signs so that we just have the A, the B, and the C, and then we'd also get rid of the spaces in between so that we just have A, B, C. And in algebra, that means that the A, B, and C are all being multiplied together. Similarly, in this next example of 3 times A times C, we'd just write 3AC and then put them close together as 3AC. It doesn't matter that we now have a number in there. We still do exactly the same thing. If you have more than one of a particular letter being multiplied together though, like in 3 times A times A, then you could rewrite it as 3AA, but really we should write the AA part as A squared, because A squared is just a simplified version of A times A. So the whole thing just becomes 3A squared. In this next example, we have 3 times A times 4 times C. So we have two numbers and two different letters all being multiplied together. Because they're all being multiplied, it doesn't matter which order we do it in. So this question is exactly the same thing as A times C times 4 times 3, or 3 times 4 times C times A. As long as we're multiplying these four figures together, it means the same thing, and we're going to get the same answer. To simplify it though, we want to multiply the two numbers together first. So 3 times 4, which is 12. And then we can tag on the A and the C. So we end up with 12AC. Let's have a go at a slightly trickier one this time. So in this question, we've got a whole bunch of numbers, P's and Q's, which makes it all look a bit difficult. The best thing to do with these questions though, is to think about each of these separately. So if we start with the numbers, we have 3 times 2 times 4, which is 24. Then moving on to the P's, we just have P times P, which is P squared. And finally for the Q's, we have Q times Q squared, which is effectively Q times Q times Q, or Q cubed. So overall, we've simplified that entire thing down to 24p squared q cubed. For this next one, we've got minus 3 times minus 6 times a. So looking at the numbers first, we have minus 3 times minus 6, which is positive 18. Because remember, when you multiply two negative numbers together, it makes a positive number. Then we multiply the 18 by the a, so we get 18a. Now this next one, negative 4 squared, is actually a bit dodgy, because we can't really tell whether they want us to take negative 4 and square it, which would be negative 4 times negative 4, so positive 16, or do the negative of 4 squared, which would mean squaring the 4 to get 16, and then taking its negative, so negative 16. In your exam, they won't give you dodgy questions like this. They'll be clear about which version they want. The important point though is that in your own working, you need to be careful to use brackets correctly and avoid this sort of mistake. Now, sometimes you might need to expand an expression before you can simplify it. And for these questions, they'll normally ask you to expand and simplify. For example, in this first one, of hj cubed, we effectively have h times j inside the bracket. And the cubed part means that we need to multiply the whole thing by itself 3 times. So h times j times h times j times h times j. And now that we've written it all out, we can think of the h's and the j's separately. So we have h times h times h, which is h cubed, times j times j times j, which is j cubed. So overall, it's equal to h cubed j cubed. For this last question, we've got 3a times 2a squared. The first thing we want to do here is expand these brackets. So we can change the 2a squared to 2a times 2a, leaving us with 3a times 2a times 2a. Next, we can do the same thing as usual and treat our numbers and our letters separately. So looking at the numbers first, we have 3 times 2 times 2, which is 12. And looking at the a's, we have a times a times a, which is a cubed. So overall, we've got 12a cubed.